Good afternoon, dear chairman, dear attendees. My name is Ihor Ivanisenko, PhD, associate professor, University of Jyväskylä, Finland, and I would like to present you our research topic, traffic sign recognition using the mask RCNN. Is brought for your attention for consideration. This work was performed by employees of the Department of Computer Intelligent Technologies and Systems, Kharkiv National University of Radio Electronics, Ukraine, University of Jyväskylä, Finland, and Kharkiv National Automobile and Highway University, Ukraine. The content and structure presented in this slide. Object detection in images is a key component of many deep learning models and has undergone several significant transformations in recent years. A separate actual task of object detection in images is traffic sign recognition. Today, there is a significant increase in the number of vehicles on the road, which leads to traffic jams and casualties. Therefore, improving the efficiency and safety of road traffic is extremely important need of the hour. Therefore, the construction of traffic sign recognition system using machine and deep learning technologies is an urgent task. The work analyzed approaches to recognizing traffic signs. Currently, image processing methods, models, and algorithms can solve the following tasks: classification of object, localization of object detection, and segmentation. Traffic sign recognition is a computer imaging task that involves identifying specific object, scan, or other feature in the image. There are two main approaches to image recognition: approach based on science and learning based approach. Today, there are many approaches to traffic sign recognition that use machine learning technologies using datasets that can consist of traffic sign images, videos, and images. The general approach to traffic sign recognition consists of two main stages: detection and classification. The most common models of neural networks which are an effective means of object recognition include convolutional neural network, CNN, autoencoders, transformers, global models, etc. The basis of regional convolutional neural network, RCNN, is obtaining a set of regions that probably contain object for classification and then their further processing by a convolutional neural network. The following variants of regional convolutional neural networks, RCNN, are most actively used for recognizing traffic signs: RCNN, fast RCNN, faster RCNN, and mask RCNN. The selection of regional CNN model for traffic sign recognition was carried out in our paper. RCNN, its features. First, RCNN accepts an image as an input and forms up to 2000 regions of different sizes on it using selective search algorithms. Each region is assigned a certain class and bounding box. Second, RCNN uses CNN to compute features for each previously proposed region. And third one, each region is classified using the support vector method SVM and linear regression to obtain the most accurate coordinates of object. The disadvantage of RCNN model is slowness and energy consumption. Fast RCNN and its features. There are two features. First, fast RCNN based on selective search algorithm processes the entry image in parallel using CNN to extract features. And second, each feature vector is fed to finely connected layers FC, the result of which is then output to output layers. Softmax to assess whether an object belongs to a class. Regression to specify the coordinates of the object bounding box. The main difference of fast RCNN R set of features is generated for every image at once, and methods of support vectors and linear regression are not used by using additional layers of the full neural network. Faster RCNN and its features. The faster RCNN, the selective search algorithm, is replaced by the region proposal network (RPN) for searching regions. Fast RCNN is used for detection. To reduce the number of regions, the non-maximal separation NMS algorithm is used, which significantly reduces the number of regions. The received data is fed into the faster CNN algorithm. And last one, the object detection model can work in mode close to real-time mode. Mark RCNN and its features. Mark RCNN is type of CNN and it's is an extension of faster RCNN. Specially designed to solve the tasks of semantic segmentation of objects in images. The main idea is to add the layer to faster RCNN architecture to generate a binary mask of each selected object. Next one, Mark RCNN predicts the position of mask, converting the detected object, solving the problem of segmentation of image instances at the pixel level, which significantly improves the recognition accuracy. And last one is mask RCNN can not only determine the location of object in the image, but also accurately outline the shape of each object. The mask RCNN architecture is shown on the current slide. In the mask RCNN architecture, two stages can be distinguished. First one is regional proposition network (RPN) for object search, and second, network object classification and segmentation mask prediction. The pre-trained CNN, such as ResNet, extracts the high-level features from an image that are important for finding the complex patterns required for object detection. A function pyramid network (FPN), by combining functions from different layers of the trunk, creates a multi-level pyramid of functions. RPN is used to identify potential objects in the image. Using a sliding window method, RPN scans the image to identify areas that may contain objects. The region of interest (ROI) align solves the problem of spatial discrepancies caused by the quantization process. ROI align used binary interpolation to accurately extract feature maps for each proposed feature region. The classification and bounding box regression are mask RCNN components that simultaneously perform object classification and refine bounding box. Thus, using mask RCNN allow you to detect objects in the image while creating a high-quality segmentation mask for each instance. Considered issues of road sign recognition implementation using mask RCNN. The work of mask RCNN on the recognition of traffic signs consists of following main stages and components, totally 5. First one, selection of RPN that contains objects. Next one, extracting signs, the images and regions selected by RPN are fed into convolution neural networks for feature extraction. Third one, main branch includes feature submission for classification and regression, similar to faster RCNN. Next one, mask head, an additional layer that is responsible for generating binary mask for objects. This layer has its convolutional architecture and is used to accurately define the shape and position of each object in the image. And last one, loss and learning function. A loss function is used which takes into account both classification and regression losses as well as losses related to mask generation. Mask RCNN training consists of following stages: data preparation, data conversation, setting of neural network parameters, neural network training, and experimental evaluation. And for this step and final step, you need to evaluate the accuracy of the neural network on an image data set that was not used for training. Results. Here you can see results, and when using mask RCNN sequence of action must be performed, it's necessary to prepare dataset with images of the object that needs to be recognized. Next, it's necessary to perform annotation for the dataset. To obtain recognition results, a neural network training application was created. After that, extracting the image achieved from dataset and annotation and assigning values to the variables was done using the web application. The result of extracting manually processed images of the dataset from the JSON file, which was made using the web service, are presented here, which shows the original images of objects left side and their images with a neural network mask right side. Considered example of testing the work of mask RCNN on recognition of traffic signs on random stages. Here in slide shows examples of original images and objects with the traffic sign left side and examples of images processed by the mask RCNN network right side. From the given examples, it can be seen that mask RCNN based on trained classes finds and processes several traffic signs in the image. This allows you to expand the number of classes and objects for recognition and improve the quality of image processing with mask RCNN. In general, mask RCNN is a powerful tool for object segmentation, which significantly improves the capabilities of computer vision system in a various fields of application, in particular in traffic sign recognition systems. Mask RCNN training is focused on the task of image object detection and image segmentation and consists of the following stages: data preparation, data conversation, neural network parameter setting, neural network training directly, and experimental evaluation of its effectiveness. Consider test examples of the work of mask RCNN on random images, which showed that mask RCNN finds and processes several traffic signs on image, allowing the expansion of the number of classes and objects and improved image processing quality. Thank you for your attention. Please, questions.